Frank?
Okay,
Because
tape
we don't know
rolls.
what
This
happened.
is the
Yes.
19th, and we are opening the box.
Okay.
Welcome back, everybody.
We got our battery, which was charged yesterday in parallel with two others. So this is number 2. Going to take this the voltage measurement. It's a calibrated instrument.
What's the good word?
Let's put it properly.
Good, Frank.
Do you want me to erase that on the tape, Frank?
No,
It's Thursday, no rules.
That's there.
no. So the voltage is shown
there.
as 12.67
7.
volts.
Thank you. Got it?
A little bit, Frank will have a solid green light, so I have to give it about 15 minutes.
Okay, good.
And they'll be right where they belong.
Well,
Well, I only tried to charge them at the 300 milliwatt level. And I just couldn't push it to it. So I checked them when I first got in,
yes.
and I told Tom, I said,
They didn't take the charge.
they wouldn't take the charge from there, but they'll take it from there.
So what is our conclusion on that one?
Hey, Jay.
Except that they are sensitive.
Well,
Too much coffee.
no pee or pen.
Morning.
Okay. Let's see your meter, right? Because I figure, I'm gonna give them about 15 minutes.
Okay, fine.
Just start.
Look, Frank, look at this battery.
Good morning, Shelley. All right, thank you. How are you? Yes, yes. No, I was just looking at something. Who called? Who called me? Yes.
This battery is white. This one's good. This battery's wiped out. Look.
Yes, somebody called me, so I'm just returning the call. Yes. Thank you.
For set first cell. Yep, we got a problem. Okay, all right, we'll get it. That's a little bit. Well, I'm gonna fire them in here. You wanna charge that? We're just gonna use these two. I would like to take this one battery and discharge these two and charge two from the one. We're gonna use this primary battery and we're gonna charge 3 volts. Okay, so you need to, what we need to do is we'll bring these up. See, look, Frank.
The test, yeah, show. Now we gotta wait and see the actual numbers.
That's bullshit. Isn't it?
Yes, hi. Oh. Yes. Maybe Debbie?
Okay.
Can you connect me to Debbie then?
That's correct, that's exactly.
Oh, yeah, sorry. Oh, my. So, yes, and I'm distracted here.
Okay.
Measuring some. So, would you know who called me?
So we're going to take the other primary battery,
Okay.
and we're going to charge 3 more.
Okay.
I don't want to go
Was it charged?
1 for 1.
There's a charge up and you pull it down on one.
Yeah.
Okay, that's good. That's good. I'll get some coffee. Right back. We'll be right back.
Charge was there.
I'll get some coffee. Right back. We'll be right back.
Charge was there.
And enough coffee for 4 people.
We'll be okay, we just need a solid green light.
Are you going to start with brand new batteries again to charge them, or just some?
We're going to discharge 3 batteries,
And then
the
recharge
machine
them
is going to
with?
do 3 more. Okay, Frank? From the 1 primary. But this time, we'll have the full primary. So Frank will drain them. You might as well drain that, Frank.
Yeah, but.
Take it with you, measure it. We'll use these.
And we have still the undetermined.
No, you keep that.
Okay.
Keep that one. This one here, right, is flat.
Which wall is flat, yes. So
Okay,
that's what I
yeah.
did.
So we'll charge these 2 with that one. All right?
Yep.
And you'll keep that one to take back and measure.
Okay, no problem. I have to get going here. So if there's a need, please.
It's a flat battery.
Call me. Yeah.
It's flat.
Thank you.
So, okay, this is one that we're
Okay.
gonna charge.
Thank you.
We're gonna charge 1A. Okay, so we'll wait because we're gonna bring this, then you're gonna discharge the one there, right?
That's
Under control, load this one. You're gonna discharge this one. It's flat. It's just static.
Yeah.
Okay?
11.68 watts. Individually.
Measure one of these out, Frank.
Yeah.
See, I have these old ones. Let's get the best of these old ones, and we'll flatten it out, and we'll do 3.
Okay.
Even though it's 450 milliamperes, it doesn't make no difference. Just a lead acid to it, right? Okay, now, you can load it over there, right? And make sure. Because that could be static. You want to put it under load? Here, I'll tell you how to check that, right?
So,
Gentlemen, we're
Milliamp difference isn't going to make no difference.
no.
Because it's on the secondary side. It's just a paralleled battery, right?
Okay.
So we know that you're going to flatten this one out. Let me mark it. We're putting this on the secondary side. And we're gonna call it 4A. Okay? So you've got a flat one there, right, Frank? That's true? Let's see.
Yes, this one was.
This is flat?
Yeah. Yes.
Okay.
Yes.
Yeah, we don't want those. Okay, I'm willing to take the shot.
Yeah.
I mean, you know, you need to flatten this cell. So while you're flattening this cell, I will let that continue to charge the primary.
What are you getting, Frank?
13.34.
Thank you.
3.
Thank you.
The individual cells for 4.3 and 4.6.
Okay, so you need to flatten that there, Frank. Take it down. Well, you can do it with this, right? Well, look,
Yeah.
I'm willing to take the chance here.
But then we still are just
You put your meter in.
flattening it rapidly, which is an undetermined.
Well, let's
state
determine
of
what's in
charge.
there. Let's determine what's in it.
We really can't, unless we discharge it gradually. We cannot determine how much is in there.
Okay, let's take it down till there's 20% in it from the original voltage.
Voltage or from
Well-
the original charge.
From the original charge.
Okay.
Because you've already determined that 20% are in the others, right?
Yes.
Okay, so make this the same.
In order to get it down to 20%, we
Okay.
need to have a charge of 4 hours discharge. If we do it rapidly,
Yep,
we only discharge one third.
okay, so we subtract the 1/3 from it. You have to leave what's there is there,
Sure.
right? We have to do it because we gotta get started.
Yes.
So I'll take that shot.
Okay.
Well, I mean, I gotta rapidly discharge it if I'm gonna do it.
Yeah. Then we just take down 15%. No, not 15. 30%.
Okay, so take down 30%, and we'll mark down on this battery 30%. Well, here's an 8 ohm, here's an 8 ohm load.
Yeah.
So that would be,
Uh,
at 8 ohms, we could get, uh,
30 minutes or something.
yeah, we got that, right?
Yeah.
While we wait for that to top.
That's 50%.
That's a better number to me, right?
Yeah. Roughly.
Okay.
That's all under the assumption that these batteries behave the same way as the one described
Well-
here.
They're lead acid, they're gel cells, so they gotta be very close. So let's go ahead and whack that down with your meter. And we'll find out right where the charge is right now, see, Frank, because if it's flat, it's flat. We want it flat anyway.
Yeah. But what do we need to do to avoid that we
Well, we
damage the cells?
Well, I'm gonna take the shot, Frank. I'm gonna charge all 3 from the primary.
So let's hook up the other meter and
Okay.
Morning,
Morning.
Doug. Morning, Tom.
Monitor the voltage
Morning, Dan.
so that we
Yep, so you can monitor it.
don't go below 9.4 volts.
I like hard problems, Frank. That'll give us time, Frank, for you to have a cup of tea, right?
Yes.
And that battery to top where it needs to go. And then we'll flatten these 3 batteries out and do the thing over. We have to live with that, right, Frank? Well, you know what's aggravating, Frank, is they don't put a chart out on that battery.
Yeah. Yes. So there are charts.
Well, there's a chart here, but I think this is assuming that, see, this is a 12 volt 4.5 amp hour. Did they show this one at 500 mils? Hey, look, there's a telephone ringing.
Isn't that terrible if the telephone rings on you?
Yeah.
This is Frank. Hallo, Markus. Hallo. Ja, bin ich.
You know, it could,
Heute bin ich
Yeah,
eigentlich
use this
bin hier
resistor.
oben in Idaho. Wir machen gerade hier Prüfungen. Kann ich dich morgen zurückrufen? Ja?
carbon cop will change on me.
Okay,
Whatever.
gut. Bis dann. Tschüss.
There's your load.
Sure.
Right? We're gonna use the wire.
Okay, that's
Better. We're almost at solid green, so we'll just let you do that.
right. Let's get started here.
You're going through the meter, you're in volts, you need to be in amps here, don't you?
No, I'm taking that one.
Okay.
Just need to have it on the other scale.
Okay. 1.45 amps,
Yeah.
good. How close is it to this chart? Then we'll know.
One, it's in between here,
Okay.
so 7.2 minutes should be. Let me time it.
You need to buy me one of those watches. Wear a stopwatch around myself. Holding pretty good, Frank.
Okay. Yes.
You actually get these hot with that little current, huh?
Well, so many watts.
It's actually holding pretty good for the voltage.
Yes.
Could you hold the meter up for me? I'll get a readout, or a picture of the readout. That would be great. Thank
So
you.
that's a current,
Current.
discharge current,
Thank you.
and that's the battery voltage decreasing.
green light, so. This holding pretty good, isn't it?
Yes. But we don't use the current current on this one because it's too high resistance.
You mean for the motor?
Yes.
So we're gonna go back to this
Prior
meter,
motor.
right?
Yes.
Okay.
So 7 minutes should be.
You know what we could do, Frank? Take it down for 7 minutes, let it sit a minute, and then take it down for 7 more minutes.
I don't think that we will provide that.
Well, then we'll just have to be recharged on the machine.
We need to make sure that the voltage never goes below 9.4 volts. Otherwise, there might be damage. And the rapid discharging is not permitted to go below 4.7 or 6 volts, so at 12 volts, 9.4 volts.
Okay.
And if we discharge at a lower rate,
Yeah.
even the voltage.
Well, I'm willing to take the chance, Frank, that it's flat, that there's nothing in it.
Okay. All right. What it's saying is, if we are discharging at this rate,
Mm-hmm.
then the capacity is only 18%. 18 times 2, 36%.
Left.
Yes.
Yeah, but
36% left.
But the 36% isn't gonna start anything or do anything, right? You wouldn't have any energy.
There is still energy. There's still charge in the battery.
Charge in the battery, but will it run anything?
Yes, it does.
Okay, so I have to give up the 36%, right?
Yes.
So let's take it down low. I don't wanna give it up.
So what is this battery was
11.
discharged as well?
Yeah, you discharged that one last night. You ran those two batteries back and forth, right?
No, this is the 450.
Okay, okay. So you need to take that one down too.
Yes.
So it's been about 5 minutes. How's our amperage and voltage?
1.2 amps
Okay.
and 10.55 volts.
Okay, thank you.
I know you don't like flattening them out like that, Frank, but I'm gonna tell you something. I don't wanna give up the percentage. I have to charge
So
3 cells.
what do you want me to do?
Take it down to 6 volts. I don't wanna give it up, Frank.
But
That machine- that-
after some time it will recover.
Well, everything will
to
recover
a certain-
after they lay in bed for a while.
But here's the charge recovers.
Okay, so we'll let it sit, take it down again. Empty that battery, Frank.
Okay. And if we damage it, then what?
Empty the battery, Frank.
Okay.
I'm not giving up that percentage. I wouldn't take the chance, Frank,
Yeah.
if that didn't happen to me over there. If I know that I'm going into the test, Frank, with a full primary battery like it's supposed to be, take it down, Frank.
But we
You don't have any fit with that, do you?
No.
Okay.
we wouldn't win anything if we damage the battery.
We're not gonna damage the
Or-
battery,
or-
Frank. Take it down.
Test would be, again,
Just take that battery down.
okay,
If you wanna take it down in steps, Frank, you have still a little time there. Disconnect it, let it recover a little bit,
yeah,
drain it back down. So why don't you do that? If you're
okay.
worried about damaging it.
So I will stop at 7 watts. So
Let it recover for about,
850 milli. Seven watts, 6. So okay, let's. So this was 7 minutes. Yeah. It's down.
okay, so let it recover a little bit and take it down again.
So we discharged
Meanwhile, I wanna have my coffee. Do you want tea, Frank?
30. We discharged 36% only.
Well, we gotta have that down there so I don't have to give up the 36%.
Okay. Let me do the other battery. So I'm draining an older battery, which we have used last time, battery voltage and current.
Thank you.
Here's Frank.
Thank
Give
you
it
very
the
much.
gusto, Frank, come on.
Okay, whatever you say. We are doing.
Yeah, you got to. See, if I have to give up this, right? See, I have to give up 36%. I don't want to give up 36%. So if you're comfortable that the cell's not damaged, and you can measure them, right?
Yes.
With whatever this percentage is, and make sure that it's at that percentage by draining it out,
Yeah.
that's fine.
Unfortunately, it's still not precise enough. And that's what I don't like.
Well, then take it to zero, Frank.
No, we can't take it to 0 because then we damage the cell with the rapid discharging. The only way of taking it to 0 is discharging it for 20 hours at a rate of 25 milliamps. That's the only way of draining it down to 0.
Okay. All right, then I guess, what do you want me to live with here?
We have to estimate.
Okay.
We have to estimate. That's all we can do.
Okay. Okay, we're down to 975,
Yes.
so,
This is the 450 milliamp battery.
that's the 450 milliamp one,
Yes.
okay?
Yeah.
So that's gonna be less than this, right? So you've already taken the one down,
Yes. This one.
okay, so we're ready with that one?
We are going to
Do it again,
do it again.
okay. It's the only thing I could do.
Yeah.
I mean,
We need to just make sure that we have some defined
well,
starting points.
yeah. So we're gonna take this down to what then?
Again, to 7 volts maybe.
Okay,
Or we stop after 7 minutes.
yeah, okay.
Yeah, pull
And
the
then
chair up.
pull the other one down and then go over there, right?
Yes.
Okay.
It's not percent, it's amp hours. So at a 500 milliamp, it's 280 milliamp hours.
Okay, left.
No, this is discharge.
Okay, I see what you're saying.
So left is then
8%, right?
no, almost 50%. Or left is 40 something percent.
Well, I can't live with that figure, but
If we actually is left then 2/3. Because 180 in 500 is almost 1.
so I lose 20% no matter what unless I take it to 0.
Yes. 5 minutes.
Okay, how do I gain back my 20%? By running the string out again?
One way is really is discharging it over time. And you can say you have a flat pattern. And this would be here. In order to drain 500 milliamp hours, you would have to run it for 20 hours. You have to drain it for 20 hours at a rate of 0.05 or 25 minutes. But constant current. And that's
Okay, I see what you're saying.
so the only way you could achieve that is using
Amplifier.
electronic load,
Right, okay,
which always guarantees 25 milliamps.
okay. And it would guarantee this too.
Yes. Yeah. Same. Yes. So we are in the estimation.
So what we need to do is, we're over here somewhere in between, right?
Yes.
What we need to do
is
is,
just double check here. Yeah.
what we need to do is add another resistor to that while it's pulling it down so it keeps the current constant.
On the primary or on the secondary? On
Well,
this discharge?
On this discharge, right, if you kept this current constant,
Yes.
instead of letting the voltage keep the current constant,
Right. Right.
you would be achieving the same thing.
Yes.
So you need to double this load right now.
It still doesn't help us. Just make sure that we are not over exceeding the law.
Okay, I just
7
will have to
minutes.
live with a 20.
Yes. We have to live with some residual charge, no matter what. So the only way of really flattening the batteries is
Can you get it to about 20% residual current?
Yeah,
yes.
I think we can live with 20%.
Okay.
well, I'd like to live with 18, but
Yeah, 20 that's as good as we can get, that's.
actually I'd like to live with 0. I don't want to give anything up.
Yeah, I know.
I'd actually like to just,
We are back.
If we had the 20 hours, we could get the
I can get more videotape.
0. No, I'm talking about, Frank doesn't have the time to stay here, say. But, we don't have the 20 hours to take it, slow. We have to go real slow to drag it all the way down. We'll have to live with the 20% residual and Frank can get that back out.
So now you're redraining the battery you drained the first time?
Yes.
Okay.
coming down quick, Frank. Pretty
Yeah, sure,
flat to me.
Sure, sure. So we have to make sure that we don't kill it. No, then we don't have nicely charged batteries. And we have a problem on our secondary side. So, how low shall we go?
Whatever you took the other one, I guess, right? So you're satisfied that there's 20%?
7.
Yeah.
Let's stop here.
Okay.
I don't want to kill those.
Yeah.
So we have
Two.
second pair and again we draining this one.
Okay.
Just taking a little more off the second battery you just discharged.
Yeah. Bye.
Well, we want to get down to 20% residuals.
Yeah.
Yes.
Right. That way,
Estimate
I
the
don't want to live with that, but
that way at least.
I got no choice.
I mean, about those 3 days. That's movement.
I'm also going to make a statement that I'm going to run without a full 18-hour charge on the primary, because I'm taking it up quick.
Right. So it's not
So-
full charge.
but we basically know how long it will run, roughly 4 hours.
Well, I'd like to get the maximum time into the batteries, into the 3 batteries that I'm charging.
Right.
Okay. That's great.
Okay, if I hear these, a little parallel, right? Stick to 450 milliamp in the center.
Okay, good.
Yeah.
Let's do it.
Yeah,
Let's see. That's this one.
yeah. Plus, to plus, to plus, to plus,
Okay.
okay?
And voltage. Okay.
We need more clips, right? Oh, we're using them over here. Oh, we're done here, right?
Yes, yes, we are.
Gentlemen, I'm getting ready for another tape change.
And we need to check these leads when we get them on the battery.
Yes.
Get
Up,
a
no
picture.
short. Everything connected. Yes.
Okay,
So in general we have 0.83 volts.
okay, so here's,
Our current.
here's your plus,
Okay.
and then this one is gonna go to the plus, right? Is that true?
To the minus, yeah. Secondary minus.
Yeah, okay.
Yeah.
Okay, so I want a
This
green.
goes to the from the plus to the plus side of the battery. Yeah.
Okay, so here,
So
to the minus, right? Okay,
going through the current coil
right,
back to the
to
plus.
the plus,
And-
right here,
Yes, and you are connecting minus directly.
yeah. Okay, now we need to beep each one of these lines.
Okay, let's do that. Just to make sure.
Well, just to make sure, Frank.
Yes.
got that connected. Frank for the check over.
Was this one?
Yeah.
Okay. Here, two, here, two.
Good.
Okay,
And this leads good? Okay.
okay. Fine.
So we're set on the secondary side. So now we need the primary.
Yes.
It's still flickering a little bit,
Yeah,
Joe?
we just need about 5 more minutes on the primary, Frank.
Okay.
Yeah, I just don't want to give up that time.
20% something hurts, Joe.
We'd rather like to see it about 5%.
If we had the 20 hours, we should do that.
Yeah. Because then I gotta run the string to make up. I don't wanna do that.
So
No, plus.
coming from the battery,
That's plus,
going to the instrument to the
plus,
plus side here, and then
minus the minus
minus directly,
to your meter.
and
Right?
then the voltage in power.
We're gonna have to,
This is not critical on whether it's, what, 90% full, 95%. Really doesn't
okay,
matter.
you wanna take it at 13.9 or whatever, 13.7?
Fine, it's uncritical how full that one is.
Well, I wanna see the whole. See that it holds this way.
This is our new primary.
Yes, it has been
And what's it reading, gentlemen?
It's going down.
13.45 watts.
Thank you.
You wanna take it there?
Sure. We will see how much, is the loss.
Yeah, if it's not bad, right?
If we, takes the hours.
Okay.
So, let's go for plus.
There.
And the minus side. So it's 13.36.
That's what, you wanna turn that on? We're gonna integrate, right? Because you want total time?
Yes, yes, let's do that.
So it says 13.
We wanna know what the amp hours are, the microamp hours. Here we go again, Frank.
Hey,
Where's the manual? I'm gonna come at you a little bit, Frank. Okay.
we start it again.
This should just be a red button on the top of the Frank that resets.
Okay.
Okay.
Integration time, let's see. Wow.
Yeah.
Go through all that and come up with the display.
Reset.
What is supposed to do? Okay, reset.
No, that's it. Okay, you want?
Menu.
Menu.
Go into menu number 2.
Right.
Select the integration time to 4 hours.
Integrate, you just had it.
Hmm?
You just had it.
Read the book again.
.28 volts.
Is it losing something?
Yes.
It's just sitting there. Is that what the meter's sucking out of it to
Yeah.
mirror? Oh. It says 2 poles spilling. What?
I need to go get my
Is it
computer.
that? Is it 2 spilling everything out? All right. I sure love the way it smells outside here. You gotta go with all those trees. Reminds me when I carpet.
Wood.
Did you get it, Frank?
Yes.
Are you ready?
Yeah. to, okay.
Ready?
Yes. All right.
We don't have connection somewhere.
Yeah, hold on a sec. Okay,
Okay,
That's-
13.26.
yes. So whenever you are ready.
Okay.
Okay.
Timer goes.
Okay, what's the milliamps? See, that battery's no good.
How much?
20 milliamps.
20,
That's where it's supposed to be.
yeah,
Let's see the battery.
yes.
Gentlemen, could you angle that flip meter towards me just a hair? Thank you.
That's one.
Thank you. Yep, beautiful.
Okay, so, that's down to 12.91 already. Cells are no good. Primary, not holding the charge.
Not much charge.
Well, that's okay. We get the time, what we put in there, then take the difference between the two,
Yeah.
right, Frank? As long as it runs it, we get the charge in there
Yes.
of what it put in, because it's doing 3,
Yes.
right?
Okay, so we are at. Move.
Okay, that's your, that is your charge to your battery.
Yes. And our speed is a little bit more than,
It's faster, right? It's about 3/4 of a second, right? A little faster?
it's almost a second.
Okay, 12.86. I hate the tones. You can tell.
John, could you take a half a step to your left? Thank you very much.
About, if that's got the charge, about 3 hours and 36 minutes.
I was reading
If the battery has the charge, but it doesn't look like that. It looks like less than 2 because there's a bad cell here. But that's okay.
And this is about the only test we're going to conduct?
Uh-huh.
Okay. Is there
So
any...
we're gonna run the string out.
Yeah, exactly.
Yeah.
Is there any advantage to me just running tapes periodically now to get meters
Yeah.
and not run consistently
right.
for 3 hours?
Yeah.
Is everybody in agreement?
It's just gonna
Yes.
run and-
Yeah.
Okay. I'm going to stop tape now at 9:51:06. Point tape again, and I'm coming around to the meter. Okay, gentlemen, what exactly am I
You
videotaping?
can say, Frank, what?
So we are looking at the battery, across the battery, and it's showing the pulse charging and the distinctive waveform, which is of course changing.
So I've got 29 minutes on our test so far.
Yes, that's correct. 29 minutes and 50 seconds. Yeah, that really helps.
Wrong button.
Have you seen everything you need to see? Oops.
So the patterns are repeating now. I think
Okay.
we can abandon that.
Okie dokie. While I'm rolling, I might as well get these meters again.
Yes,
Just to
please.
see where we're at. Still holding strong at 12.4 volts. Okay, I'm going to go ahead and shut the camera off and let the test continue. Again, almost 1 hour into the test.
Does it make sense now, Frank, what's happening?
Yes.
You see, if you pulse charge a battery, the battery moves itself backwards in time. That's how you get the sustained charge. That's how come you can take that dead battery out there and run it for that long, but the conventional one can't do it. See, it's true, you can charge a battery either way, but which battery do you want? Do you want the one you're going to put in your cell phone and dial the number and have it go dead on you, or do you want one that can sustain the charge? And the reason it can sustain the charge is because of the way you charge it. It makes its own energy, Frank. There's nothing hidden out there. You can't find anything hidden out there. The battery makes its own charge. Now, if they understand the process of what's going on in that battery,
Yeah.
the chemical engineers could make a battery that automatically would accept that and run hours longer at a much lower voltage rate. See, it doesn't have to be at 14 volts to be charged with this battery. That's the typical, yeah, this is the way we do it, this is the textbook thing. But I guarantee you could charge one to the same level with a charger out of the wall,
Yeah.
and this one that comes off this machine, and that one will run 11 minutes longer, because we did the test. It's something so interesting, Frank, that it just boggles the imagination of where we've been all this time.
Inefficiency.
Well, we push current. We really don't need any current from it. We don't have no current, we don't have no heat.
Yeah.
We don't have to run a fan to
Frank,
pull more current.
And we have no losses.
Right.
Frank, is there a dilemma in the ability to both quantitatively and qualitatively test the system so that you have confidence in the accuracy of the testing process itself? Is there any dilemma in, not the methodology, but we need more instrumentation, or is there some kind of a process that we're not doing that we need to do to further
Factor
explain
time.
what's happening?
Factor time. Yes.
Extra time,
Factor time, actually.
yeah.
If we would be able to discharge the batteries,
Mhm.
we need to zero, which needs to be done in 20 hours
Mhm.
with a very low current.
Uh-huh.
Then we could build up from there, when we don't have the unknown of how much charge is in those batteries. It can be anywhere from 10 to 25%
Okay.
still remain.
So can we do that? Can we, you're talking about draining the battery with a very low current,
Yes.
slowly drain the battery over
But
a long
it takes
period of
10,
time?
20 hours to drain the batteries in accordance to the documentation of lead acid batteries and this type of capacity. So,
I'm gonna go ahead and stop the tape now.
okay.
This one is after it interacted, going out in all directions from this dipole in any interaction is in three space.
Yes.
So here I got three space waves going everywhere, spreading in all directions from this dipole. This one is not in three space at all. It's a phase conjugate, so it's got that minus I in there. It's over there in that time domain.
Yeah.
So in four space, this is my three-dimensional world down here. In four space, what I have is I have the energy coming in here and then spreading out in all directions like this. After it interacts with that charge.
Yes.
And that's what I did to solve the problem of the source charge. I just simply reinterpreted that wave right there and pointed out that he had both of his waves interacting, so he had no cause and effect. If you have only two effects, you forever lose the cause. You can never explain where it comes from, which is the situation we're in right now. But if we reinterpret that wave for where it really came in, so we have a cause, then you had a solution to this formidable problem that's been there since the beginning of electrodynamics. What's called the source charge problem.
Yeah.
Now, the way you solve the source charge problem is very similar. Any charge, if I use quantum electrodynamics, in the vacuum there's a clustering of these virtual charges of opposite sign. If this is a minus one, these are plus. And they continually appear and stay there. And while one is there, this is a dipole. A piece of this charge right here with this one makes a little dipole. So it's a set of dipoles.
Yes.
To show the virtual ends forming and unforming all the time, I called it a composite dipole, set of dipoles. Because this one forms and disappears, forms and disappears, forms, but it's always there. It's always on the average there. So what happens is I can treat the source charge as if it were a whole collection of these dipoles and the same thing applies. And that's where the energy comes from. Now the way we get it in there is real simple. Once we understand this is what a potential is,
Yes.
the energy is entering from the time, coming out in three space in every direction, because we measure it in three space after we interact with a charge. So once I understand that, the vacuum itself, the ambient vacuum, just emptiness here, we know from quantum electrodynamics, for example, very active. Tremendous energy density and all this stuff is bubbling away and disappearing and forming and disappearing and all that. You know all that stuff, the Feynman diagrams and the whole thing that describes all that. So that's a well-developed body of theory. That's not Tom Bearden. So what we have is there's a very high, at any moment, there's a very high energy density, electrical energy density.
Yes.
That is, in fact, a phi, and that's the phi of the vacuum, the ambient vacuum. And in theory, the way we treat it, we don't want to look at curved space-time, but in theory, as long as the space-time ain't curved, that ambient vacuum everywhere would have that same vacuum of the universe. That's a universal thing. What any other potential I make is simply a change, a local change to that vacuum. So when I make this, what I really do is I change this vacuum. But you see, this is the same thing. This is those waves coming in all directions, but coming out of the time domain. And now I make a change that comes in. So when I make a potential, if I make a potential where I can use both directions, I can catch some extra energy. If I just use one direction, forget it, I'll come around my loop, I'm lost. The way we do it in the battery, the way we're able to use it, and get a little bit of it for extra. Let's try to draw this battery here. Okay, I'm going to have an external circuit out here, which is just a resistor, and then I'm going to draw some terminals here of the battery, and these are my two plates, and they're connected to the terminals. Now, actually, for ease of drawing, I'm going to make the other terminal down here, all right? So that's my ground terminal, let me say, and this is my hot lead. Actually, between the batteries, I have different kinds of ions, of various molecules that ionize. And the main thing is, for an equal charge on this thing, the electrons, which move basically this way, from the outside of the plate back to the outside of this plate, these electrons, the mass per charge ratio, that's very, very small. That approaches zero almost for the electrons. It is real, but it's very small. Very small mass of the electrons, so and a fixed charge on it, so that's a very small value. Now, for one of these ions, that mass is enormously large. Even a proton, for example, is 1,800 times or so more massive than that electron. So in these ions, I have M per Q ion.
1.6 times
You know,
minus 9.
say 1,800 times if I'm just using the lightest one, what could possibly be, which is a proton, you see.
Yeah.
And usually I got a proton and a neutron and some kind of molecule and this stuff on it. So really I'm normally up there in, many thousands times heavier. Well, it's nice because of the mass, it has inertia. Now electrons, unless we're extraordinarily high frequency, for power systems, we don't consider electron inertia.
What is it now?
Inertia. You put a force on it, it resists the acceleration for a moment before it picks up the velocity. Okay, but these ions take longer to pick up any force that you apply on them.
Yes.
So if I produce a very high spike right here on this plate of electrons, the electrons move extreme rapidity and they pile up on this plate. They're not permitted to go anywhere else. Well, let's say I had some ions in discharge mode coming in here. This would be discharging. I back pop this battery. Well, what happens is, as these build up, the charge density, Q per LQ, Q per volume. The volumetric charge density goes up. They just keep piling in there. So what happens is, that's a higher potential. So this thing goes up a little more, and I have a lot of potential on this battery. Not my normal 12 volts or 16 volts or whatever I would charge it with. I have like 100 volts on it. Well, you see, that's energy. That's joules per collected coulomb.
Yeah.
So every how many coulombs here, I got a whole bunch of extra joules, momentarily. But it was a momentary transfer of extra energy.
Yeah.
And by the time they turn around and start to move, they got the extra energy on them from the pulse.
Yeah.
But see, I didn't pay for that. The electrons never went any further with current than here, and they're starting back out here this way now.
Yeah.
So I didn't have to pay for that little bit of extra energy that I added to those ions. Every time I pop, I get a little more energy on those ions. And when I'm charging the battery, the ions resist being accelerated by the charge. I still build up to the 100 volts, and I still get extra volts momentarily on them, so I get extra energy added to them. Excite the ions a little bit higher level of excitation state. So the ions I'm using to charge are in a further excited state than the normal ions when you recharge the battery. That's where we get the energy from. We get it right out of here, and it comes out of the time domain. That's why we refer to that as if we were time charging.
Yes.
When we took that thing that we corrected from Whitaker, you say, then we had the energy enter. It got into real energy. It came out as it's a real voltage. It's absolute, you can measure that spike going up in voltage. You can capture it, and it's a real voltage. It's not fiction. But we normally do not pop a circuit that has anything but electrons in it. So whatever I do in this direction does exactly backwards in this direction. I kill myself to begin with. I can't capture that in a normal circuit. When I spike the normal circuit, you never see it. But if I have a different two circuits, the circuit is divided into two different mass per charge ratios, which the battery is.
Yeah.
Only in that case will this process work. It's the only way I can catch extra energy. If I had electrons over here,
Yeah.
I would kill everything just as fast as I help it, and I haven't gained anything. But because I have this hysteresis in response, the delay in response to those ions, I can put extra energy on them, have it caught, I can be gone, the energy then has to be delivered by the moving ions. So I actually get the ions into a higher excited state. And that state, when it hits, gives up that extra energy. That's where we get it from.
We're about.
It's kind of strange, but it's a real process. It's a physical process. Nobody ever thought to, most of us when we went to school, they never told us that we had to consider two separate currents when we had a battery powered circuit.
Yes.
In fact, every diagram they draw, what do? We draw a thing here, and we draw it this way. And nobody ever says that we have a different M per Q out here than what's in here. And as long as I don't deliberately get my timing and all, when my pulse is set just right, I will never see it anyway. But if I get it right and I take advantage of the fact I have two different circuits, and I can even make them go in different directions, I can get them out of phase with each other. Once I can do that, I can get energy. Once I can break that absolute phase, I can get extra energy. And in electrical engineering, if you grind that through, that'll convert it as if you were able to convert reactive power to real power. You got some free reactive power and you convert it into real power. That's another way to look at it. But it only works in this case.
Only in case of a battery.
Well, only where, there are certain plasma
Yeah.
circumstances where there are different ions here, you see. The ion doesn't have to be electrons, the plasma doesn't. And so I can get it in plasmas because I can get the same different kinds of circuits going. I can get it in batteries real good because, they have a whole bunch of ions between the plates. And the battery manufacturer already built that plate to separate those circuits. He's got a special coating on that plate and a special construction of the plates, you know all that stuff.
Yes.
So he goes to a great deal of trouble to where he wants this current real nice and he wants this other one real nice here. He does all that in his manufacture.
Yes.
But he gives us then a tube where if we understand this process, we can call it, for a good solid word, call it overpotentialization. We can get a little bit of free overpotentialization of the ions, which is an excitation. It raises their excited state.
Yes.
And it gives up that extra energy when it strikes the other plate and
Sure.
helps recharge the battery. Change the chemistry back to the different form of lead. So that's what's happening.
We're a minute 30 into the test. I've just recorded all the measurements, and I'm going to shut the camera on.
Meter, you're trying to read pulses,
Yes.
the digital meter can't read it correctly.
No.
You have to use an analog meter.
Right.
So
And this guy is trying to
Integrating.
interpret that, and it can't.
it's
it
integrating
seems
something.
Time to
No,
roll, John?
Certain
This
level.
guy can interpret it.
Oh, yeah, that's a visual.
This guy,
Okay. We're
From-
at
visual.
from
1 hour,
whatever you do over there on
59
the
minutes
bench,
in the test,
if you understand the lead acid battery,
and we are rolling tape, gentlemen.
and what happens in that battery, you will find out that when you pulse charge in rapid succession like that, it's times 3. Because on a normal charger, it's only 1/3 of the scale. Or if 1 amp on a pulse charger will come down to 1/3 of an amp. But technically, the peaks are going up to that 1 amp. This machine is not fast enough to catch it.
Well, that's what I'm saying. It's digital.
You can't even look at that.
You're not looking at
It's always
visual.
depending on the quality of the analog digital
Signal.
converter.
Yeah.
And they are.
You know how I found that out, Frank? In 1972, there's a preamp sitting up there on the thing.
Yeah.
It's pulse charged with the correct type of pulse charge. That preamp that's sitting up there is a pulse charged preamp. That's how I found that out.
Pulse charge preamp.
Yes. This preamp,
Amplifying audio.
yes, this preamp sitting up here to this day will do identically what that order. It's a pulse charged preamp running on batteries. There they are. And the circuit is very strange, Frank.
Yeah. So who did that?
You me.
When? When was it?
This is 71. So I've been charging like this. You see these two capacitors?
Yeah.
This capacitor right here just filters the supply. This capacitor gains a charge and snaps the batteries. And it does it through a pulse width modulator. But it's still, if you look at it with a scope, it's deep, 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 deep. And rings those
Separates,
nine cats. Yeah, I don't give a crap. If you put zinc there,
Yeah.
it'll do the same thing. In fact, if you put an alkaline battery and place that battery, it'll go up so fast that you go, oh, geez, something happened to me.
It's going to explode.
No, it's not going to explode. That's the very nice thing about a pulse charger
Yeah.
with a sharp peak.
Because it cannot,
It automatically
cannot accumulate
limits,
the heat.
right, cannot accumulate, it goes the other way. See, this battery charger over here, you put this charger on the battery, what happens to the battery is the battery builds internal heat because it's trying to push, right?
Yeah.
The more you heat the battery, the more damage you do.
Yeah, the more you are.
Right.
Working
Why
against-
does your car battery in your car only last 3 years? They got it figured out, Frank.
Yep.
It's an alternator. 100 amp alternator, Frank. Okay, but you want to know something that's very strange? If you really calculate what's running that car, it's only 3 volts. It's not the 12 volts. Yeah, everything says 12 volts, but the battery only needs 3 volts over to keep your headlights running.
Okay, I'm gonna stop tape.
Okay.
Yeah.
Okay, we're rolling tape. It's 2 hours, 27 minutes into our test.
Right there.
Yeah.
They took it apart on me. Remember that, Tom? And then I called them up on a stage and I said, come on up here and measure this. And it was switching 4 battery banks back and forth in a circle. Remember I showed you the little battery thing yesterday?
Yeah.
Well, this was doing it with a pulse modulator and all these transformers to get that spike on there. Because I learned from popping the batteries, and then with this preamp, right, I said, oh, this is a piece of cake. This guy had sent me a little drawing, and it was the most crude drawing you'd ever seen in your life. It had little boxes with wires between these boxes. He says, oh, you have to figure that out. And I don't know how long it was before I figured it out. And then everybody tried to change it.
Well, you've been a pioneer
What keeps you?
ever since we've been doing audio. You have been a pioneer
Yeah, I've
in
been
sound.
what they call a real sidekicker for him, I'll tell you that.
Oh, yeah.
Frank.
It's getting a little slower now.
Visibly slow.
It's all right, it's gonna die.
Just about to go.
Yeah, I'm just gonna continue to roll in, gentlemen.
Frank will catch it when it goes.
Whoa, our timing is excellent.
Good.
There she is, Frank.
She stops, and what do you got there, buddy?
So the time was
I've got 2:28.
2:20 and 43.
So the battery was less than 80% charged.
Yeah, it was down pretty good.
It did not charge last night. Right, and that's the only reason why.
So let me just record those numbers.
And what was it yesterday? 12.15, right, Tom? Look, 12.15 with less time on the primary battery,
Right.
which means you got more charge,
That's correct.
because you were running at 900.
Battery charges like this, you see.
Yeah,
The last hour or so on that other charge is not getting much in there.
So and we accumulate.
well, the funny thing about this thing is, the slower it goes, the more it pops it.
Right.
153,
But
60.
did you notice the light on that preamp, Tom, when it was flashing? It was 1 second pulses.
Yeah, same thing.
Yeah, has to be. Here, voltage, right here, Frank, look.
1250.
Yeah, it registered and recorded it.
I like those techie scopes. They're good scopes, aren't they, Tom?
Yes, they sure are.
Yes, they are better than my fluke.
Yep. That's a good scope.
Frank likes it too.
Yeah.
The better one is this analog dinosaur.
Frank's
Tom.
been playing with it now, so.
Yeah.
153.67. But this is my client.
That's your client? Well, you know what you ought to tell them, Frank?
Everett.
Say, you can be my client, but you know what? When you're not around, give me the techie.
Micro and hours. Oh, it's
So
still
it's
recording. Oh, I shouldn't say
153.
who is my client.
Tom, it's 153.67 times 3.
Micro and hours.
Those batteries have received 4.6 amp hours.
How did you determine that?
I can tell you.
Okay,
Right.
yeah, no, but
How did I
Let me-
determine it? I can
Yes.
tell you that's what they got. You can test
What
it.
do we need to do now, Frank?
We need to take one of these and run them over.
What do you wanna do?
what is the best
What's
To
the
do
best
now.
way to determine it,
Yeah.
right?
to do now?
Well,
Think about it a minute. Let him think about it a minute. Let him think about it a
Yeah,
minute.
you think about what
Frank.
you want to do,
In-
Frank. Those
in
batteries
that way-
are lock solid, they ain't going anywhere.
I would like to take one of them
Yeah.
and discharge them with constant current, but I can't do that here. So
You're taking
have-
one.
I have one already,
Yeah,
and I need to
wrap it up so it doesn't short.
properly mark that, yes. So if I can take...
Do you want
one
this
of
in a little tiny box?
it,
It needs to be something so it don't short.
I'll make sure it doesn't short, because I'll tape these over real good.
And they'll take
which
one of these.
Which one?
You pick
You
it.
pick what you want.
Don't take the 450 milliamp.
No.
Frank, you know which one this is because of the number, right?
Yeah, it should be 2.
Yes,
You have that written down in your file?
yes,
Okay.
yes. And
You can
I'm
just
going to
disconnect
take
them.
I'm going to take this guy here as well.
Okay.
Okay, and that will be,
I will discharge it with a constant current
Right,
using the electronic loads.
right,
And that's one of our new batteries, 1A.
yeah.
Okay.
Yes,
Started out as our original primary, I think.
yes, correct.
Yeah, and that's the bad one.
That's a bad one.
Yeah, that's the one where the voltage difference is in the cell.
Let's check.
pardon me, John, I'm gonna get a shot at
Okay.
testing it, make sure it took something.
Let's check the voltage.
What is this?
12.11. Let's check the cells. 402, 404, and 403.
Okay.
Yeah. So
Beautiful.
they are all
Close,
close.
okay. You wanna check this one?
Yes, please.
Okay. This is
the
still moving, but this
450?
is
No,
the,
this is a 500.
yeah, then you wanna check that one too, because you want the highest set of cells.
So maybe
I'm gonna leave this like this.
1216.
Yeah,
408, 404, 403. So there's not really
Okay.
a huge difference.
all right, okay, so
But
choose
you would
which one you
prefer
want.
that I take this one?
No, I prefer you take what you want. You
Okay.
check this one.
I don't mind.
I don't mind.
1219. And I need 408, 46,
Number 2.
404. Thank you.
You know what?
So-
You've seen the same thing in those batteries there, Frank,
Yeah.
in that.
Hey, pick one there and take one over
Yeah,
there.
you pick whatever you
You
want.
pick what you want, and I'll go wrap it up for you.
Aye.
We'll take this little bitty 450 milliampere. This is depleted battery, right?
Yeah.
This is a depleted battery.
Okay,
yes,
good.
To
We'll take this
whatever.
off here, we'll take the
10%
450
probably.
milliamp one, right? And charge the 500 milliamp one.
Which is still,
Discharge.
oh,
Primary.
so you are changing.
Yeah,
Yes,
yeah,
okay.
you'll hook it
Okay.
back up.
You want me to wrap that one and I'll mark
Yes,
that number
please.
3?
Yes,
And
please.
you'll mark down number 3 on yours, so you know.
So we'll reconnect here, Frank?
So let me just, so 1/3, just make sure that I have all the notes.
Frank, are you getting hungry?
Yeah, we'll go on
Hungry?
here.
Hungry? Yes.
I'm just worried about you might be hungry.
We'll go in just a second. We'll let this run because,
Yeah.
That's,
Now, is this something, John, needs to be documented?
yeah.
This next test?
Yeah.
Okay, so we got,
So you need to film it and
Absolutely.
and I'll just take them.
yeah, perfect. Now, would this be something I'd do in the increments again, or just let it roll? Because this will be another 3 hours, right?
No,
Oh,
just let it roll.
okay, my pleasure.
Just let it roll and you gotta stay with it.
Oh, I will, absolutely. Just need to know what I need to do.
Stay right on it while it's doing it.
Give me some epoxy, I'll stick my feet right here.
We nail his feet to the floor. On both of those.
Yellow's plus, right, Frank, yes.
yes,
And black is ground.
yes.
Okay.
That's just the voltage.
Okay. And then this one is,
This one is coming from the current loop, so
okay,
it's going through the meter,
to
coming
yellow,
back
right?
to plus.
Plus is here. And then yellow is plus.
Yes, it is.
Black is black.
Yes, black is,
Okay, here's number 3. You're all set.
yes.
Okay. Then the scope is here, right? Okay, whenever you're ready.
So you get your new primary hooked up
Yeah, well, this is the recharge from the,
from the last test?
gee, Frank, it went up in voltage.
Which one?
This one here, the 450 milliamp gained voltage. It's now up to 1221.
There's coffee.
Hey, you've got a CD over there. I thought I was probably the only guy in Spokane that had one.
No.
Mark Morrison?
Oh, no.
You remember Mark?
Yeah,
He painted my barn for me. And I'm like,
that's what's left, right?
yeah.
That's all there is.
I really liked his style. You ever seen him play? He just taps on the strings and he sounds like a synthesizer. Son in Seattle, he's working at a grocery store, just trying to get away from it all.
Can't blame him.
So is that by chance your parents that walked in here? Is that
No,
Oh.
that was Mike and Lou.
Oh.
Bibbin. Actually, Mike's almost 90.
He's up there.
He's pretty close to 90.
Yeah.
And Louis Sal or something, I think. And Mike doesn't need Viagra.
Oh, no kidding.
No kidding.
Do they have a new kitchen?
Oh, we do that ourselves here, thank you. Yeah, the new kitchen was an addition to this.
Okay, good.
Should we just run down and get something, Gary?
I still have that stuff left I put in the refrigerator yesterday.
Is it any
Went out
good?
on the- Yeah.
Wanna eat it up, don't
I mean, there's
Frank?
stuff left there, and there's bread, and there's,
Okay, pull it out.
make a little sandwich, and you're off and running, yeah.
Then we're gonna have to leave the test.
Yes.
And then you can get some.
It's all good. I'm not gonna starve in 4 or 6 hours.
You never can tell.
He just fell over. I don't know what happened.
Yes, this has been continually going on, Tom.
Yeah, there's fresh
Ever
vegetables
since a
here.
kid.
Strawberries.
If my mom was alive, Frank, she'll tell you I was running my whole garage on batteries. Never used their power one bit.
Well, it's
Frank has to reset the thing every time he wants to do it. It's like it doesn't clear its own memory out.
Well, I'm gonna stop tape till we're ready.
Yeah.
Okay, when you start that, then we can sit down. There's drinks in the refrigerator.
Timer goes. We just started the test again.
Okay, so
Jumping in
we're,
on me.
we've got only about 350 milliamp hours because our time was short.
Okay, there's your time on how long we've been running, 57, 58
So that would be
seconds.
divided by 2, you'd be lucky to make 1 hour.
There's our primary.
Oh,
Or there's our
more like-
charging.
Yeah, right, that's what I said.
Here's the motor.
I'm gonna give you the hour like you do.
There's our voltage. There's our amperage. Now she's starting to hum.
Yeah.
Would you like me to run this with no cuts? Just 40 minutes?
No, you can stop, because we're all here.
Okay.
Yeah, we're gonna go eat.
Okay, we're gonna go eat.
And oh, there's one more meter I need to get. So way over here it's saying 11.49.
That's the charge rate into the,
Charging battery.
into the primary.
Okay, I'm going to stop
And then
tape.
cover those, John.
Rolling tape. It's 18 minutes into the next test. And here are your meter readings. Voltage that the charging battery is getting hit with.
The real point, John was yesterday.
It's what's left over, right?
The real point was yesterday.
I'm not sure what this
we hit that
is.
Point, we had to get to the COP ones.
Yeah.
And Frank knew what that point was.
Charge
So
left in the
once he-
primary.
He saw the point.
Amperage, drain rate.
But it has to be done this way.
And that
It has
little
to be-
motor.
It has to be measured independently. It's not good enough for us.
We used to do it all the time, Frank. You don't sit up in front of conferences and things like that. When they look at it, it's like a new paycheck, so. Candy or somebody would have done that. You know what kind of battery you would have? You had a battery, Frank? You popped one time, man, it would have a 12 volt.
What I want to see out of it, you know, we have the thing at a small proof of principle level. And you've had it for 20-something years.
I've been trying this for.
Okay, with the energy crisis we have, we need everything we can, the whole world, not just Americans, everybody's in a problem. We must go back and pull out again those equations we threw away.
Yeah, you got it.
And we must build these kinds of systems, because that's the answer to the energy crisis.
That's gonna save our butt.
We need to get something extra. That's not going to be for fossil
We can't
fuels
put all the
and-
fossil fuels in there. We
Well,
gotta
they-
dig the oil out of the ground.
If this all heats up, though, Tom, like you said, they're dependent on this happening.
Okay, I'm gonna stop
No,
tape.
I hope we do.
Oh, what I read last night is horrible.
Okay, I'm rolling tape, and we are 37 minutes into the test.
37?
33.74
Yeah.
milliamp hours.
Yes.
And this,
They're almost at 12 volts there. So see, Frank, as the resistance goes down, the voltage goes up.
Yes. Yes.
Hey, Gary?
Okay, I'm gonna stop tape until we're very, very close to the end. This would be a cut.
Only thing is, we ain't got
Okay,
the
we're
drum.
rolling again, 45 minutes into the test.
We got a little phonograph motor running, detail running, stuff like that. Forget what he was quoting, he was quoting something like 2.5, 3 months. He's running a 7-watt light bulb. Yeah, they just flying away. Yeah, and eventually, Robert Lee took the idea and got paid off, and that was it. But all my thinking was always the primary, secondary. And then switch. It's like we're going over there. So and it may have, as it hasn't been, but to do this, you have to build.
I'm gonna stop tape.
Out of a battery that didn't have the charge, but now this one does have the charge. $99, almost 101 microamp hours. And it's popping that one pretty good, Frank.
So, for documentation
Yeah,
purposes,
we're charging the 500 milliamp one with a 450.
That's good, that's good. I would rather see more capacitance on this one.
Well, we're just depleting the string right now.
Yeah. See, when that delta peak occurs inside that battery, the amount of energy you collect is a direct relationship to how much charge you have in that battery, how many ions you have.
Yeah,
So the more battery capacitance, the more battery ions to collect.
right. So we got a while to go. 48 minutes, it's already went over what we said, 45. So that,
It's still going, literally.
well, that little guy over there, man, has quite a capacity built in it, Frank.
Still running.
You know that?
yeah, so it was charged for 2 hours and 20 minutes. And previously it had maybe, let's say, 20% left.
Yeah.
2 hours. 20 minutes.
He's just wailing away, Tom.
It's not gonna go 30 more minutes, I have confidence. I'm just gonna roll this tape continuous for the end of this.
No, I would stop a little bit. It's gonna go.
Yeah.
Yeah, it's
Still
gonna
running
go.
pretty good, so
Yeah.
I'd go be slower than that.
Okay, we'll stop the tape now.
Yeah.
I'll wait. All right, we're cutting.
I'd rather be sure than.
Hey, we're rolling.
A little while yet.
The current decreases
Thanks for.
rapidly. So let me go and stop. Whatever.
So we got 5739,
A little
Yeah.
way, Frank.
still going.
Still going.
Yeah, it's gonna go a little bit.
So this current will tell us when it's going to die.
It's almost like this one has a second wind though.
Yeah, it's putting up quite a fight.
Yeah.
Still maintaining the current. Also the voltage is down already to 8.7 volts.
And it's still about 12 volts going into the charging battery.
500 milliamps. Yeah, 50. Come on. You can make it to 1 hour.
Check, 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 check.
It's determined to run a little bit, Frank.
Yeah. 59 minutes and 24, 5, 6. And so on. Still going down to 40
Now
milliamps.
begin to falter a little bit. And it gets another little grip, and it falters a little, and it gets another little grip. Getting
Almost 1 hour.
Pretty good, Frank.
1 hour is.
There it is, 1 hour.
She's going now, she's slowing down.
Yeah.
Just not gonna give you a break, huh, Frank?
Well,
It's going there now, it's got.
Yeah, he's got it.
okay. So this was 1 hour. Yeah, almost exactly 1 hour. Whatever the charge is.
Should we test this battery on camera to see what it is? Although I'm sure it's, I shouldn't be sure of anything.
Test it in what?
Just to make sure it took a full 12 volts and, I don't, you tell me. I'm
1184.
Okay.
It shows the voltage here. So 3374. Why only 83 volts?
You need to run that one down too.
Okay,
Where's John? Here.
let's do it.
Yeah, we need to hook one more, another down.
Come on, it's rolling.
Yes, sir.
Go this way. It's a long way.
Well, it made it over the 45 minutes, didn't it?
1 hour. 1 hour.
Had quite a charge in it, though.
Yeah. We're getting quite a charge out of it.
Okay, then we ready, Frank. Have time. Ready?
So, no, did you switch already?
Yeah.
Okay, I don't know if my guy works here.
About 25 minutes, and we'll have 3 batteries.
That was Chinese dust, Frank. Just like the article said, mustard colored, that's exactly what they said.
Yeah.
Well, wait a minute here, Frank. This battery's the 450 milliamp battery, so we didn't switch.
I knew it was dust, I knew it was mustard colored.
Right, I disconnected that one and put it here.
Okay.
We always-
I will have
This one has a 11.8, so we got about
Then I'm gonna go in there.
about 250.
Like mustard, it was a dark murky yellow.
What happened is, the dust from the Mongolian desert was pollution from China all mixed together.
Yeah, didn't have pollution.
Pollution has a lot of China pollution.
We're going to be divided by 3.
Yeah, they said.
I flew through it
With
coming out of
constant.
Salt Lake City.
Yeah, but will it stay up there and eventually?
A lot of winds will blow it off.
It happened another time. It wasn't the dust, it was actually the wind was blowing so hard that the pollution was
Makes me walk off.
No extra charge.
No extra charge.
About 34 minutes, this should be over. That's taking a total charge, dividing the charge in half, reducing the primary battery to only holding 250 milliamp hours. 250 milliamp hours because of the time, which makes the battery about 45% efficient. Dividing that by 2, give you about 35 minutes.
39.
About 30, 35, right in there. And it should deplete the strength.
Yeah, I should go right now.
So the total charge would have been 500 milliamps. Automatically, knowing that the primary battery was about 55% in the beginning. We couldn't accumulate the charge. You see what I'm saying?
Yeah.
Because we were shorted on the motor end. So 250 milliamps divided by what the motor's gonna pull, and then divide that by 2. Comes out to be about 35 minutes, is all it should go. If we accumulated enough charge in a battery that's a pain in the ass anyway because its cells are different.
Yeah.
I'm gonna stop the tape until we're ready to conduct this next test. Thank you. Cut.
I need this battery, Frank, and you need to connect with it.
Okay.
Camera rolls.
There, minus, right? To minus, to minus, to minus. Okay.
Okay. Plus. Oops, we lost one.
Okay.
Come on.
So now we're rehooking up the old primary as the new receiver.
Okay, now
charger.
typically, this battery moved itself up. It's now up to 82, so the potential is still climbing on it. So whenever you're ready, okay? I still
Alrighty.
give it 35 minutes,
Okay, ready?
okay?
Timer goes.
Yes.
Pardon me, John, I'm gonna record the readouts. So this says that we have 11.51.
Yeah, see, we're at 100 and we're at 90 milliamps, typically. So we'll call it 100 milliamps, right? So, okay, 250. We'll give you 2.5 hours if it was really there. At 250 milliamps, it will give you 2.5 hours if it stayed constant, but it's not. It's going to move to 120, see?
Yeah.
Don't want to go back where it came. So, about 35 minutes.
Okay, tape rolls. The next test is underway.
We'll see how close it is, honestly. Goes over that, then I feel real happy.
Okay, with the test underway, I'm gonna stop tape.
Boy, she's rolling in. We're about ready to deplete.
Yeah, I was over there gabbing. I should have been paying more attention here. Let's see, we've got 20 minutes, 8 seconds,
Yeah.
and we've got,
It made it longer than we thought, right?
Yes.
and still 11, 8 going in.
I forgot to take that. This was the one that the outside cell gave us trouble last time. So actually, we've done a harder test than everybody thinks. Tough.
You're just lucky we didn't bet money, John. You'd have been buying the beers.
That was close.
You're close.
Well, I gave it that cell, right? I gave it that this battery. I didn't know that this battery. I should have looked at the number.
Okay.
21 minutes.
21 minutes.
Starting to slow.
Maybe 22 minutes. Actually, did better than I thought. No, it's going to quit around. See, remember it did that last time.
Yeah.
Identically the same each time.
Yes. What the current is.
For 40 mils. Now, if it could sustain the 40 mils, it would just keep doing that. Yep, see?
Yeah.
There she goes.
She did. She's not triggering. She will.
And there she is.
I've got 20 minutes, 40 seconds. What'd you
Yep.
get on yours?
20 minutes, 34.
Okay.
So we just need to deplete Frank one more time.
Yeah. Just record.
Okay, I'm gonna stop tape until we get the next test rigged. Cut.
Okay.
Okay,
go.
tape rolls, timer goes.
Timer goes. Yes.
Not getting any voltage
Can
over
you,
there.
well, this isn't going to take very long because we're at 100 mils. on certain flashes. 90 mil. So maybe about 10 minutes.
Okay. Do it, John, why don't you take a
And
step
your
back
speed
and
should
I'll
be about 800
get all the
frames.
readouts. Thank you, John.
It's definitely got the two batteries balanced, almost. Oh, she just gained a little extra bit. Right. She just went into resonance.
Speeding up now.
See? It's like the battery got extra breath of wind there for a second, Tom.
Got settled in again.
Yeah. About 850, isn't it?
1.2 seconds.
Yeah. It's at 100 mils now. Almost 11, so,
Yeah. This increased speed.
yeah. Goes into a resonant point and locks in, and it's like this battery got this 450 milliamp battery. Remember what I said? It's easier with that battery than it is with a 500 milliamp battery, because the resistance is different between the two batteries. So you know, Tom, what makes a big difference is when you're looking for batteries, you want a battery that's got a high current rating but a high resistance to charge. You know what, Frank? That's where these lithium-ion batteries come into play, because they got a higher resistance.
Yes.
Or nickel hydride, excuse me. The NiCad is low, but the nickel hydride has a sustained charge level because of its resistance is higher on the initial charge rate.
Lithium, iron, and
Yeah,
so on.
yeah,
Might even be better.
yeah. Well, if this would have been a lithium-ion battery, you'd have made 4.5 hours with no sweat at all. And it would have been easier to charge.
My integration here just continues. It didn't reset.
Well, you're just depleting charge, Frank. You can't have over the other one.
But I can give the accumulated.
Yeah, well,
Treated as valve, treated as travel.
Yeah, if we would be able to exactly evaluate the waveform, sample the waveform, we would be able to read it directly in M hours. If
Yeah.
This one would be good.
yeah, if you could do that. They're still holding 100 mils, 110 mils. This definitely, this battery here is a better battery, Frank.
You should say 450.
Yeah,
I just ain't got nowhere with
it is exactly what I'm saying. It's the impedance difference, the way you fill the bucket.
So what?
Well, this replaces that because all the people said, hey, I'm running out of power,
Yeah, sure.
right? They didn't realize that they can't really even fully charge these.
Yeah. That's why Sony changed models.
Yeah. Yeah, the cell phone, if it's got a lithium ion in it, Frank, you probably do real well. Is that what yours has got?
Takes a week
Yeah,
almost.
Yeah.
Standby.
yeah. Yeah, because of the sustained charge
Yes.
in the way that the
Right.
ions are.
Yes.
Yeah,
Yeah, and then it charges in
about 2 hours, right?
less 1.5 hours.
Yeah,
Little guy here.
yeah, right.
4.2 volts,
Yeah. Same battery.
800 milliamp.
Mm-hmm. Basically the same thing, isn't it, Frank?
Yep.
Well, this little 450 milliamp battery is going to go a little bit longer, I would think.
Okay, so we're at 21.5 minutes with
Maybe.
the other one.
Yeah.
So we are getting close. Last time with the 500.
610?
You're already at 612.
34, then 21, then 11, and then 9.
Yep. You're gonna have to deplete it again, Frank. Cut that one back up. See? Yeah, see? This one here is a different,
Yeah.
and it's holding a lot. 100 mil, 10.63. You know this battery will run down to what last time? The motor quit?
He's running down all the charts, it actually
8 something.
Yeah.
Yeah, it's around 8 something.
Yeah, the other one quits at 9.
Yes.
I bet you it's damn close.
He is running, I like it, he's running on push.
And then deplete that one, and we're done.
Yeah.
Even if it's 2 minutes, Frank.
Yeah.
Right?
Yes, we take what every bit we can.
Good estimate.
And if in 2 minutes it's got this one back up, take some more. Looks like it's doing a pretty good, hefty job because it's holding. It's holding at the 100 mil. Looks like it's holding at the speed too.
Yes. That's why.
Yeah.
Calibrate load test to see how good his estimates. Right. You have other people do it too. So he's trying to do some good.
Well, it's popping that one pretty good, Frank. Just jumping around. See, blink that screen.
11, 8.
Yeah. We're gonna have to take its charge. Actually, you know, technically, in the beginning when I first started playing with, I've been playing with these little motors for a long time, according to my notes over that time.
Yeah.
Ever since 84, 85.
Before that, John, I met you back.
Well, I'm talking about this motor.
This one, okay.
Yeah.
But you had a little motor working when I first met you, I met you
Yeah.
before that.
Gary, I'll tell you, was from one extreme to the other.
Well, you made me go learn some more electrodynamics. I didn't know enough. But it's possible to explain what you're doing, what I do. And even with the other stuff, I couldn't find out how it was working. I figured out
Yeah.
circuits.
Well, when Gary and I first started that preamp, Tom,
I had the same.
the
I had
people
same-
loved them.
I had
They
the
couldn't
same
believe that
problem
it charged
right
that quick. And run the entire 8 to 10 hours, way past the NICAD time.
I had exactly the same problem Frank had. Where the hell is the extra energy coming from?
Well,
How's it getting in there?
We know where it comes from.
And as long as I had that circuit one closed loop, I couldn't find no place, nowhere for no energy.
You cannot never close loop. In other words, you can't take this output and run it back here, Frank, it defeats itself. You gotta have two separate things. And typically a motor generator, right, you get less out of the generator than what you're putting into the motor. But under this circumstance, you get more because of the potential.
Well, the real, as far as I was concerned, the
Where are we
real
sitting at? We over 10
flash
minutes?
bug that went on
Yeah,
was the
almost 11.
simplest
We're,
equation.
we're over 10 minutes, Frank. This is what I told you about this battery.
The real flash bug, John, was the simplest equation in all of electrodynamics, VQ.
Yeah.
And I looked at that and I finally realized if I had enough Q, like a lot of Q in
Yeah.
the battery, and I could make a little bitty extra potential, I had extra energy in that Q. It's already available. in the-
Yeah, it's already available in the coil.
But you gotta make that little extra potential.
That's right.
You don't have an over potential, you can forget it, you're not doing anything extra.
Well, 90 milliamps, we're gonna make probably damn close. Probably over what that one did, Frank.
Really?
Well, think about it for a minute. 90 milliamps in 10.4 volts to, she's coming down.
Can you scoot back just a hair, John? I'll get
Suddenly
those straight
it
out.
goes rapidly.
Yes, it does, because you're depleting the full charge.
Yes.
You're getting rid of that 20% that you were talking about.
But you lean back and I'll get those.
Thank you.
Maybe this one runs down to what, Frank? 8?
8, or maybe even lower than 8.
Now, you know, it'll go to a certain point and stop there. It should.
Yeah, because the current
Yeah.
decreases.
Right, and
It's
the
always
two, you know, the two do
8
something funny too.
Yes,
One starts to balance the other.
yes.
Just, did you make about 12 minutes?
Really? Well, I'm gonna change tapes.
No, I'm saying it did it.
Oh, yeah, we're just past 12 now. 12 and a half. Okay, engine, don't fail me now.
No, engine won't fail you. Go get your tape, man. You got a little while.
A lot of time. All right.
12 and a half minutes.
Okay, I'm cutting tapes.
That's kind of. You got about 855, 60 mils. She should quit it around, what, 40 mils? 50. She won't quit as long as she bounces up to 6.
It's slowing a little bit though.
Oh, yeah. It's down to about 150 RPMs, 200. 50 mil. She's quit about 40.
Putting up quite a fight.
Oh, it's fighting. It's battery's fighting to hold the 50 mils. Plus, remember, it's got a discharge, and it's fighting against drag.
Yeah, that wind resistance is a constant, isn't it? The air.
Pulling a wind paddle, man, is not an easy job to do. Was that easy, Tom? You could blow yourself down the freeway, right? 40 mils, Frank, coming up. Actually, it's about 45. She's not gonna die on you until it gets to 40 solid. There she goes. Soon she won't trigger now. So you go down to 3 there?
Yeah.
So in between the two, it's really sitting at about 45, 46 mils.
Yeah.
She does. Can't stop the timer though until it quits.
Yes.
See, 30,
Yeah.
50,
It's fighting it.
take half of it,
Yeah.
right?
She's going now.
It's done triggering. It's down to 1 mil.
There she goes.
Oh, she is, yeah.
I got 15, 20 on the watch.
Okay.
15, 20, yes.
She almost outperformed that battery right there, Frank. Now we need to switch one more time, Tom.
Yeah, you can if you want to.
No, we have to,
It'll reach a point where it'll continue at that level, probably.
yeah.
Okay, I'm gonna stop tape till our next test is ready.
All right, all we're gonna do is, see if these thick guys could make a probe that would stay together. We should. Just a sec.
Oh, she's reading.
11.36. Surface charge. Okay? We're gonna go.
Timer goes.
Timer goes.
$70 mil. 80.
Yeah.
90.
Want to come up with speed?
Yeah. Well, maybe not. There can't be much in that battery. This is a problem battery.
Obviously.
But that's okay because it doesn't really make any difference, does it?
No.
We're up to 100 mil. 90. 100 mil. Peak 100 mil. Boy, it puts the charge there, Tom.
Maybe in a situation where you decrease to a certain level, it will never go away. You know, the extra charge you get in the other battery will be making up for the losses in the state battery.
Yeah.
No matter how you change the
Go
battery.
back and forth, back and forth. It's got that one cooked back up again. It's gonna be hell to deplete these. But you should really deplete them, and that way you're at zero, Frank.
Well, what you're running into is the residual time charge that's in there.
Yeah.
It'll make that difference. It should do that. It should come down to a level where
They can run each other.
they can run each other.
It took it
But
longer,
you
but
set-
now it's
but you
making a
set it at
noise.
a certain kind of test.
It's 100 and something mil. It's like I got a breath of wind all of a sudden here.
Yeah.
That's your time charge.
Yep,
That's
you're running on time, Frank.
quantum field theory, that's called the time polarized photon. They don't know how to make these, but it appears in the theory real well, which means you also have time polarized waves.
Yeah,
That is time polarized photons produced in this thing a little bit. It does do that kind of charge.
yeah.
Now, we'll have to get that established one of these days, because they don't have that established in physics yet. They have the time polarized photon, but they don't know how to make it and charge anything with it.
That battery boosted itself up, Frank.
Yep.
This one. This problem one. It's at 100 lock solid. Full up 900.
So the only unknown we have right now for comparison is how long would a full 500 milliamp hour
If it was
battery
fully charged.
How long would it?
Well, it would go, I can tell you how long it would go. We're gonna take the high.
Mhm.
So we've seen this thing go as high as 140 milliamps, right?
Yes.
So I'm gonna give it the highest. I'm gonna say 150. I'm gonna short myself by 10. So 500 mils, if it was fully charged, 18 hours,
Mhm.
divided by, we'll go with 150 mils. 3.3 hours, and we know it'll do over that. So that high is wrong.
So just use the 120. I think that's.
Okay, so here we go.
average.
Well, we have to
Average.
split the difference because it goes down to 100, goes up to 140.
Yeah.
So we're gonna take 130, right?
Let's take it 120.
Okay.
That's the longest time we are seeing the
4.1 hours,
4.1 hour.
4.16666.
That's not
So-
too far off your curve.
So this would mean that's quite similar to the 450 milliamp hour battery.
Right, it is actually a 450 milliamp battery that somebody's put a 500 on and up the
You
price.
mean Radio Shack
Yeah,
does
of
that?
course.
They probably do.
You can figure it out just by doing this,
Who's
Doc.
gonna dispute it?
No, but who would know?
They'd say, oh shit, I got a new battery for my.
No, but I mean, who would know, guys? You know, we're doing tests here, you'll find out.
Would be a little performance.
Yeah. What could you lose
New-
on a cell phone?
Well, it's a sale, new and.
1 minute worth of talking time?
You know all them 450 millimeter batteries, milliamp hour batteries you got? Yeah. You know all them 500s they need? Yeah.
Yeah, here, big,
Put the
big.
label on.
That's right. That's what it seems like, you know that, Frank?
Yeah.
That's exactly what it seems like.
Somebody wanted 450 that year, and now we want 500.
Yeah,
Same battery.
it's the same battery. It's an identical battery. But if you take it apart, it's got the same number of plates and everything.
Yeah.
What a cheap shot.
That's a cheap shot, yeah.
Radio
That's
shack.
typical.
That sort of thing is done more often than you would think.
Yeah, well.
Well,
5 minutes.
yeah, 509. Well, it went past what I said, Frank.
Are you getting into that residual now, John?
Yeah, but we want it. We want it out of these batteries.
You won't get it out of these batteries from now on.
It'll just keep going back and forth like this.
The time charge is at some point where you cross where the time charge becomes a predominant effect. You reach a point where it's changing back into ordinary charge fast enough to keep going, is what you're doing.
Well, that's okay. Then I should build a machine to run like that.
In theory, if batteries
theory.
keep doing that,
Right.
you could run forever. I said in theory.
In theory. In theory.
No, let's say in practical.
In practice, you could run far longer than any textbook or any college.
Yeah, but this is great. This is building me time.
Of course. You could run longer than any textbook would ever
Frank
say.
probably don't like it, but it's building me time, huh, Frank?
Textbooks do not have time charging in them.
Well, it's a time effect, isn't it, Tom?
It's a time energy effect.
Yeah.
John, why don't you lean back?
Yes.
again?
Okay, this is gonna quit, Frank, because this battery has that weird cell. But we have to take the 450 milliamp battery and go over here. 993, 70 mils. When it gets to 40 mils, she'll quit. Actually, I think this battery quits at 9.8, what, 5 or something?
I hear it slowing down.
Yeah, okay, 600.
6, almost 7 minutes.
Yeah. Now, if we go back to this one and it does 7 minutes,
Yeah.
we quit, right?
Yes. Okay.
Because then the two are balanced.
Mhm.
We actually want two balanced batteries. So it's just the time charge that's running the machine.
Eventually, yes, John. All electromagnetic energy that gets into three-dimensional space comes from the time domain first.
Right,
That's not in the textbook yet, but we do have a paper published saying it.
okay?
10 years from now, hopefully that'll be in the textbook.
So 10 years from now, if we go 10 years, we should be able to tap time and generate energy.
Everything we ever built, John, electromagnetic, is running off of time as energy. Everything. Remember I told you the dipole?
Yeah,
The energy comes in first from the vacuum in terms of the time domain in the complex plane, out there in that time axis. It gets transformed by those charges
has to
into
say
ordinary
3,
energy
Frank,
and
it
poured
has
out
to
the
flash
first
3
place.
once.
That's where it comes from.
4.
But
So
see,
she
the
flashes
the
3.
solution to that didn't appear till
I'm
last
looking at
year.
that blade, it's getting slower.
Well,
and
yeah,
slower.
it's gotta do it, it's gonna flash 3 in a second. Says 50 mil,
There it goes.
40.
By the way, I ran that by Evans before I published that paper.
This one here quits on you early.
There's the slightest thing anywhere.
But this
wrong with
one
that
will
tear
have
apart.
almost approximately,
No way,
should
do I
be
want to publish that, it's just not rigorous. He came back and said, there's nothing wrong with it, there's no error. in it.
40,
It works
see?
that way.
30. She gonna quit.
You know,
Yep, she'll quit.
it's-
30.
Blade's going slower.
30, well, she quits triggering. She saves the battery to right where you want it anyway, Frank.
Yeah.
So it doesn't take it too low?
Yeah, it doesn't take it too low. Thanks to the dial.
Got just under 9 minutes.
Yeah.
8:55, 8:58.
Okay,
Yeah.
this is one last time, Frank.
8:55.
It's a one last switch. You wanna switch first?
Yes. That's when we're close the time.
What time was your flight, Frank? Do you remember?
5:30.
Okay,
We don't have
Time is it?
more running
We got a
over
little bit of time.
Well, that's all right, I'm still on.
Okay, I'm gonna stop tape until we're ready for the next test. Okay, and your analyzer's ready?
Yes, it's ready.
Okay.
Okay.
My timer's ready.
Okay, here we go.
Timer goes. Camera's rolling. And I'm gonna get a shot of the numbers.
Should only be about.
John, can you lean back just for a second? Thank you, sir.
She's up to 80 mils now, climbing 90. You're right, Tom, just boom, 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 until you deplete it. Well, maybe you can't.
Don't know, the battery may have something in the way it's constructed.
So we have
Compound or
4A
something.
as the primary, and we have battery number 1 as the receiving of the charge type battery.
It's definitely a time charge here.
Battery number 4.
See, that scalar potential voltage is made of longitudinal waves in free space, plus longitudinal waves coming in the time domain. So, when I say
100 mils.
all the stuff that comes in three space has to come in from the time, because basic potential from which everything is made, that's the way it's working.
It's gonna go into
And
resonance.
see, nobody corrected that until last year.
You
Before
know,
that,
that's
everybody put it in
popped
free
up
space,
to
so the
100
active
mils,
interaction,
right?
and that's an error.
Take the peak. She's in resonance. That's a damn.
Someday we'll laugh at all this, because the vacuum is so energetic, so much energy in the vacuum, it almost boggles the mind. And as we get better in how to get it out of there, you know, there won't be an energy problem. But we gotta get started first. We gotta get the scientific community started actually letting these young guys work on that.
You running?
Yes, sir.
She just went into resonance.
Good.
Ooh,
Yeah, I have the tape
I
and
think
the
you got a second
resources.
win there, huh?
What would be an interesting test would be to see how long you can alternate two batteries like that. You know, just do a sheer endurance, how many times you can alternate. After they get down to that, after they get down to the tail end where they cross that time
Yeah.
switch, it'd be interesting to see how many times you could change it.
Well, Frank wants to do it one more time. We'll do it.
He hasn't got
He
the
didn't have time.
John.
Gotta go to the airport.
We don't wanna make him miss his area.
No.
I don't know, we want to get there a little bit.
100 mils, Frank.
Yeah.
She's well on the way, Tom.
I'm excited about the next set of tests.
What do you got on there, 8 mils?
3.5.
3 mils.
You're fine, I always lose it.
Yeah. You know, there'll be a point where the 450 milliamp battery will overshoot that one.
Could be, I don't know.
It's getting real close to the 450 overshooting the other 450 that's marked 500.
You got a pretty good little grip that time.
That takes a good charge, that one, Tom. It's a good cell. It's holding right up.
So it looks more realistic.
Monday's fine.
Here she comes.
Drop dead goal to have Mike will call you, get the address and get that thing fixed.
I'll provide that to Michael and Bill can connect it to Frank.
That brings up a new machine, Tom.
Yeah, 2 or 3.
Yeah. Maybe it is possible.
It's 2 or 3 small principles. First of all, there's no such thing as a closed system in the universe once you have an energetic vacuum, which now, of course, is well established. So everything
die.
is in an exchange with the vacuum. And if you can keep a disequilibrium, some broken equilibrium in there, where you can keep having...
60, 70, we should be depleted on the batteries, because this can go on forever like
Particle
that.
physics 50 years, almost 50 years ago, proved that the dipole is a broken equilibrium. I don't have to prove that.
Right, sure.
They gave
It's not delivering
Dr.
too
Lee a
much
Nobel Prize
energy.
for that.
Oh, no, it wouldn't.
Because
You're just depleting the battery.
And in particle physics, what that means, rigorous...
But if you want to get your 20% out, you got to do it.
Receives virtual energy that just pop little piece, another little piece, it's never big enough piece to grab. But if you absorb them all, so that they keep adding up like dust particles hitting the floor, it builds up into real dust.
15. Same thing
So
again.
the charge can absorb that virtual
6
energy.
minutes.
Yeah,
And it builds up during its absorption, to where it's big enough.
That's a better
for real
battery.
energy. It spits it out as real energy.
They should have never changed it,
It's
right?
something you can't use in its normal form. Turns
It's
into a
5,
form that you can
4,
use. Becomes
coming
real,
up.
in other
As
words.
soon as I see the 3, it'll quit.
So the point is, that was proven almost 50 years ago, and we're not using it yet.
One, 3, come on. You should quit. Right. Keep trying. 3. 3. Quit. 2. Don't want to die.
Trying really hard.
It got a good night's sleep and good breakfast, it's still working.
Yeah.
7 minutes and 40 seconds.
7:40.
What was the other one, Frank?
9 minutes,
Okay.
25.
Got time for one more?
One more, Frank?
Yes.
Okay, we're gonna go again. I'm gonna stop tape till we're ready for the next
Just
one.
one more and that's it, because Frank's got to go. Ready?
Okay, tape rolls. Click, timer goes. We're rolling again. Now we have
Nah, you ain't gonna make it, Frank. I think we're pretty
4A.
well depleted.
Receiving the charge.
Picks up a little more.
Wait a little bit, see how much it picks up. I don't
Up
think,
to 80?
I don't think that's as good a sale as that other one was, so.
Oh, no, that is a 450. Mm, 70, 80,
Look at
90.
minutes.
Oh, yeah.
John, could you scoot back for just a second? Thank you, sir. Rolled over the shoulder shot.
Now we went back and forth, talk back and forth, back and forth.
Not getting quite as good a grip on this other one.
Oh, it's in there. It's up at 90 mils.
Okay.
Close to it on the peak. About 85 mils.
Yeah, it didn't come right up there like that other one.
It's in resonance right now. got that other battery pop right back up the same place again, Frank. You could do this forever. That's interesting, Tom. That means that you
particular
don't
chain,
need,
if we had time to run that 3 or 4 days, that would be very interesting, because if it'll do that 3 or 4 days, you blow the battery theory right out of the market.
it's already blown out of the market if you
Blow
go
the
back
chemistry-
again.
Blow the chemistry and everything else out of it, see?
Has nothing to do with the chemistry.
You can't get that kind of stuff out of chemistry. You keep going under a load, under a load.
It's going under load.
Okay, follow you.
That's right, huh, Frank? Can't get it out of the chemistry. It's got to come
If
from
it
somewhere
did,
else.
wait a minute, that's an if.
Yeah, well,
We gotta see that it does it first.
it's doing it.
Well, it's starting on, it looks like it's on the front end, but let's see how long this one goes.
2.5 minutes.
Gonna make it about 4 minutes.
Well, that means 10 then.
How long that other one make?
7:40?
I can see this one go about 7. 6:40 at least.
Mm,
No, it's dicey, but I said I'd like to see it do that. But the 2 batteries are not quite matched.
that's right, they're not matched.
So,
She's fighting at 9, 9, 9, 10, 9, 9, 9, 10. She getting some extra, because that was 10 too.
yeah, look at that rotor.
Now you know what's happening here, Frank? Look at your meter. Watch. Well, it ain't gonna do it now that you're over here.
Was jumping?
It was flashing. Didn't know where to go for a minute. See that jump up like 9.3, well, milliamps are pretty constant. Unless it's percentage points after that. You gain a little extra with a 7.
Yeah.
Just getting a little extra push somewhere, Tom. It's only a theory.
Right.
Speed. Of interest.
Yep, now you know to buy a techie, Frank.
Yeah, we have actually 2. But, somebody gave me the bad ones because of a certain feature which the other one doesn't have.
Just bounce to a 4.
Got a little bit to go. What's the time?
4:35?
435.
On this?
4 minutes, 35 seconds.
I want to see that 640, John. 7
No,
if we can
because of the imbalance in the batteries.
get- 7 if we can get it, but 640 would be nice.
She's not gonna make that.
It's beginning to go.
Yeah.
Beginning to go.
Yeah, because of the imbalance.
It's not gonna make it.
Even though you know you got your finger on it, Tom.
It's slowing up. It's just about to get off on it, can you? There it goes. Bingo.
5:20?
Yep, 520, okay, but you see, subtract what the difference is between the 2 cells, and you did make your time.
It's interesting.
You could do it again, but Frank ain't got time to do it.
No, we don't want to make him miss his airplane time.
No.
Unless Frank wants to.
No, I don't think he wants to miss his airplane.
Frank, is there anything you'd like to say on camera in the last 5 minutes of the tape? Get you the
No,
dub as soon as
it's been
possible.
an interesting time.
Okay.
Thank you everybody for the inputs, and yeah, now I have to put everything together.
Okey-doke.
I'm going to take 2 batteries, one which we charged yesterday and one which we charged today, to completely drain them and determine the amount of charge as accurate as possible. And yeah, this will be, in addition, giving us some data which we need. Yeah, and hopefully at a certain point in time we can have the big machine run
Very good.
and charging back and forth car batteries.
Okay, with that, I'm gonna stop the tape. Concludes our test.
Okay, good deal.
Thanks.
Yeah.
Very good.